Alright, in this video I want to talk about using statistics to help us make better forecasts. We should always use statistics and expert opinion, I think, to get good forecasts. One without the other is not enough. So the first thing I like to do is graph the data. So here I have some sales data, and let's put a graph on that and see what it looks like. So we'll put the scatter diagram down here and pick our data, add the sales. Here is the x values, which is always the number of data points. And then this y value is always the data. So here is the data being put in. Hit the button, and okay, so it looks like our data is a little bit curvy, which may mean we need to use some kind of exponential equation. But a straight line might also work. So we right-click on a data point, say add a trend line. Let's try linear first, display the equation, and display the r squared. We pull that out of here so we can read it. That straight line that was just drawn right there explains 87% of the variation in those data points. Not too bad. You could make a forecast with that, but we should check and see what the exponential would look like. Add trend line, we go back. This time we say exponential, display equation, and the r squared. Let's see what that looks like. The r squared is way better, 99 point some percent. So this exponential curve is way better explanation of the variation in the data points than the straight line. What that tells us is we need to do a forecast using an exponential type equation, which is exactly what the growth equation is that's in your textbook. The growth equation is 1 plus g, the growth rate, raised to the nth power, which is the number of periods, equals the ending balance divided by the beginning balance. If we would take both sides and raise both sides to the 1 over n power, we would have 1 plus g equals ending over beginning balance raised to the 1 over n power. Putting that into our equation for today, 250,000 divided by 12,500, that's the ending and the beginning, raised to the 1 over 17. Since there are 18 data points, there are 18 minus 1, or 17 periods. Not 18 periods, 17 periods. So when we do all that, we get 1.176. That's the growth rate. Taking that growth rate and multiplying it by the last value of 250,000, we get our forecast. Our forecast is 294,000. So graph it first, see which fits best, a straight line or an exponential. If it's an exponential, use the growth rate formula. If it's a straight line, then use a straight line formula. Okay? Here's another situation. Let us graph this one and see what it looks like. Okay, for our data points, let's just get rid of that. Something's going on there. Okay, add price. This one is price. Now our series X values are the periods, number of data points, I should say. And then we put in the values, which are those. And that should give us our equation. And geez, it looks like a stock chart or something, doesn't it? It's up and down. There's really no mathematical equation that can fit that one. But what we have to do when we get a situation like this is go to moving average. So when you get a nice fit with an exponential, you can use the growth equation. When it's a nice fit to a straight line, you use a straight line. And when it's zigzaggy like this one, you have no choice really but to move moving average. Okay? So we can right-click our data points, go to trend line, and we can put on what the moving average curves might look like. So here is one where I will pick the number of periods to be 6. There that one is. That doesn't explain the variation of data very well. There's a lot of movement away from the line on these data points. Let's try another one. Let's try the trend line again, go to moving average again, and on this one, let us pick 3. Now that one explains the data very much better. Much better. Goes along much closer to the points. That one's probably going to work out the best. what we have to do is verify that by doing an analysis. So what we do is we put in the moving average data. I'm going to show you in a minute how I filled this chart in, but here's the 3-period moving average. Our forecast using this data would be 9 for the next period. What we do is say, well, what would the 3-month average say our 4th period would look like? It said 11, and it was 11, so the difference between those two, forecast minus actual, is 0. So here's forecast minus actual for each of these data points down through here. Square them all, and here's the squared variation. It adds up to 110. Now, if you do a 6-period moving average, of course, you start your first forecast is on 0.7, and we did the same thing here. Here's the forecast. Here is the forecast minus average. That would be this minus this. Gives us the forecast minus average, and then we square it, and that's our squared data variation. It's larger. So just as the graph showed, the 3-month is closer to the data points because the squared distance between the 6-month and the 3-month is better at the 3-month. So that's how we would then choose a 3-month forecast, which says the next data point we'll predict should be 9. Okay? And if we wanted to put some kind of tolerance around that, it would be the 110. Take the square root of that, which would be in the neighborhood of 10. Divide that by the number of data points, which is 17. 10 divided by 17, that's just a hair over a half. So we're saying that it would be somewhere between 8.5 to 9.5. Okay? That I wanted to show you how I got the 3-period moving average. If we go to the data analysis screen over here, which is an add-on in Excel, everybody who gets Excel gets a data analysis, but they have to follow the directions in the help screen to how to get it open. And mine has been open for some time. Here is moving average that I picked, and I picked this column right here. And my output range I picked was right there, C161. This one looks like it's ready to go. And there it is. There's the 3-month moving average data. Now notice that it came in with the first data point at 3 months. We actually want that to be our forecast for the 4th month, so I moved them down. These can be eliminated. And then you got to clean up these data points that are way too big. So we go back to the home screen and shrink those down to 1 decimal point and continue down like that. And if we continued in that fashion, we would end up back here, which is what I did, clean this up. So that's how we decide which moving average is the one to use whenever we have a zigzaggy data set like that, which looks a lot like stock prices or something. You pick the one that gives you the best fit. So I hope this helps. See ya.